In this video, we'll do a brief summary of some of the steps you do for graphing a polynomial function, plus a couple examples. Now first, when you're graphing a polynomial function, the first thing you want to do is to find the intercepts, which if it's in factored form, that makes it easier to do. If it's not in factored form, then you do have to factor the polynomial. Then you would use the multiplicities of the zeros to determine the behavior of the polynomial at the x-intercepts. And then you would also determine the end behavior of the graph by examining the leading term and the degree of the polynomial. Now the last two you could switch which one you do first, although to find the degree of the polynomial, it can be helpful to find the multiplicities of the zeros. Then you use the end behavior and the behavior at the x-intercepts to sketch a rough graph or a rough sketch of the function. And then optionally you could use technology to check the graph. So let's do a couple examples. Let's say if we said to sketch, let's say the function f of x equals to -3, let's say times x plus 2, that quantity squared, times x minus 1, that quantity cubed. So this one is in factored form, so that does make finding your zeros of the polynomial function, which gives you the x-intercepts, quite easy. So the zeros in this case, well, you look at the factors, so -3, that has no x in it, so that won't give you any zeros. So we have the x plus 2 factor, so setting that equal to 0 and solving for x, you get x is -2, that's one of your zeros. And then doing the same thing for the x minus 1 factor, by adding 1, like setting equal to 0, add 1 to both sides, you get x equals to 1. So those are the zeros, which are also the x-intercepts of the graph. Now the multiplicities of those individual zeros, well, let's see, for this -2, the degree of that factor is 2, so that would be the multiplicity. Similarly, for the x equals to 1, the degree of that factor is 3, so that would be the multiplicity of that zero. So that tells us that at -2, since it does have an even multiplicity, that it will touch but not cross, or will bounce, as some students like to say, at that x-intercept. And at 1, since it has an odd multiplicity, that it will cross at that x-intercept. Now by adding these two multiplicities together, you also get the degree of the polynomial. Which in this case of the 2 plus 3, which is 5. So that's an odd degree. So that tells you for the end behavior, on one side it's going up and on the other side it's going down. Now remember, if it had an even degree, that means it's either on the far left and far right, it's either both going up or both going down. Okay, so with this information, and now we also know that if we multiply this all out, the leading coefficient is -3, so that'll help us determine the far right end behavior. What I would do next would be sketch the graph. So one thing I would do is to plot our x-intercepts, so -2 and 1. Also, if you wanted to find your y-intercept, what you do, remember, you plug in x equals to 0 into here. So if we plug in 0 in for x, f of 0 would be, let's see, -3 times 2 squared, so that'll be -12, times -1 cubed, that'll be -1, so that'll be +12. Okay, so that would be our y-intercept. Now, since our leading coefficient was negative, that tells us for our far right, so we take our farthest right x-intercept, we do know that it will be going downward. Now, since it has an odd degree, that tells us from our far left x-intercept that it'll be going in the opposite direction, so that it'll be going up. Now let's see, we could just go from left to right now. So at -2 we had an even multiplicity, so that told us a touch but does not cross, so that it bounces, so that it should be going back up. Then it'll cross this Y-intercept, and then we do know that at 1 it does have an odd multiplicity, so that tells us we should cross, which goes along with the rest of what we know about the graph. So this would be a rough sketch of the graph of this function. Now if we wanted to, we could check this using some graphing tool, like Desmos.com is a great one to do because it is a free online graphing program. So plugging it in, let's see, so x plus 2, that quantity squared, x minus 1, that cubed. So yeah, so that does tell us that that looks pretty similar to the graph that we did draw ourselves. Okay, now obviously if we wanted to get a more exact approximation, we plug in some other points, like maybe if we plugged in -1 into this, we would have seen that it went really high up. Like I said, we're just giving a rough sketch of the graph. So let's do another example. Let's say if we do sketch the function, let's say x cubed minus 8x squared plus 16x. Now in this case, this one's not factored, so what we'd have to do is to factor the polynomial. Now one thing we could do, remember, always the first thing you do when you try to factor a polynomial is, can you factor out a greatest common factor? In this case, we can factor out an x. So let's see, that would be x squared minus 8x plus 16. And that actually does factor to x minus 4 times x minus 4. So that'll be x minus 4 squared. So that's the polynomial function in factored form. So our zeros in this case, well, so we have x times x minus 4 squared. So x is one of our factors. So setting that equal to 0, we get x equals to 0 is one of our zeros. And then also setting the x minus 4 equal to 0, we get x equals to 4 is another one of our zeros. Now each one of those multiplicities, well, let's see, for the 0, that has the degree of that is just to the first, because it's just x, like, which is the same thing as x to the first. So the degree of that 0 is 1. Now the degree of 4, since that has the factor is x minus 4 raised to the second, the degree of that is 2. For the degree of the polynomial, well, in this case, since it wasn't factored, it was easy to see that the degree of the polynomial was 3, which again goes along with the sum of the multiplicities is 3. And that the leading coefficient, well, the leading term was x cubed, so the leading coefficient is 1, which is positive. Okay, so we could now give a rough sketch of this. So let's see, 0 is one of our zeros. It's also our Y-intercept as well. And then 4 is one of our zeros. We have a positive leading coefficient, so that tells us on the right that it's going up. Now it's an odd degree of the polynomial, so that tells us on one side it's going up, so that must be on the other side it's going downwards. Let's see, at 0 that had a multiplicity of 1, so we do know that we cross there. And then at 4 it did have an even degree, even multiplicity, so that tells us that we bounce, we touch but do not cross at that x-intercept. So that would be a rough sketch of that. And then again, checking that on, let's say, with the graphing tool. See, so x cubed minus 8x squared plus 16x. And yeah, that was a pretty good rough sketch of the function.